Welcome to Chapter 2 for all you Algebra 2 students. We're going to go ahead and go over some words to review. These may show up as vocabulary on your test at the end of the unit, so you're going to want to get these down. All right, to begin with, let's talk about the definition of a relation. A relation is basically any set of ordered pairs. Any set of ordered pairs. That means you have an input with an output. The domain equals the inputs. All right, in general, the x's will be our inputs. The range equals the output. And so if domain and inputs are x's, then the outputs are the y's. And this is just typically, I mean, you could set your variable to whatever you want, but this is the typical one. So a function is a relation, so it's a set of ordered pairs. And you need to understand that each input has a unique output. Now that may not make sense like this, but basically what that means is if you have a function, if you have some equation, here's your equation, okay? If you have the input of x equals 2, and you may have seen this before where you've got a function machine where 2 goes into the machine, some stuff it's messed with, and then out comes another number, let's say 3. All right. That means whenever you put x equals 2 into the machine, into the function, you get 3. So that's what this means. That means you're not going to have this. If you put a 2 in there, all of a sudden, magically, you end up with a 10. This isn't a function. The machine is broken. An equation in 2 variables. Basically, it's an equation. I think we'll just write here an equation in 2 variables is y equals mx plus b. We're just going to use that as an example of it. Basically, you have 2 variables. You have an input and an output. A linear function, we're going to say again, is still y equals mx plus b. Over here, I could have said that this is an equation in 2 variables. That's an equation of 2 variables because the variables are an input, your x's, and an output of y. So anytime you have an equation and there are 2 variables, it's an equation in 2 variables. Linear functions are written like this. And there's another way that you can write them, and you'll see it in a minute. Slope. There are a lot of ways to use slope. Slope's definition is the change of the output divided by the change of the input. All right? You see it like this. Change of y over change of x. That means y2 minus y1 over x2 minus x1, which is rise over run. There are a lot of ways to think about slope. Okay, parallel lines have equal slope. They are equal distance. equal distance apart from each other. Perpendicular form a right angle, and their slopes are opposite, reciprocal slopes. So basically what you'll have here, if one slope is 2, then the other slope is negative, the opposite of the reciprocal. So the reciprocal is 1/2. The opposite of positive 2 is negative. Rate of change is just like is slope. It's basically slope comparing two quantities or units. So it'd be dollars per hour, things like that. Parent functions. A linear equation has a parent function of y equals x. It's basically, let me go back to black, most basic form. So that means the most basic form for linear, y equals x. For quadratic, y equals x squared. For a cubic, y equals x cubed. For an absolute value, y equals the absolute value of x. Basically, there are no coefficients or no coefficients. You're not dividing by a number. You're not adding or subtracting anything. It's the most basic there is. The y-intercept is location in equation crosses y-axis. That's the y-intercept. So here's a graph. Here's a line. The y-intercept is right there. Slope-intercept form. Y equals mx plus b. So y equals b. M is the slope. B is the y-intercept. Makes it very easy to graph. Standard form should be in the form ax by equals c. And this is important to know. This is another easy way of graphing if you know how to graph intercepts. So that's just what it looks like. X-intercept is the same. It's the location of an equation where it crosses the x-axis. So now there you go. And for this one, the x-intercept is right there, where it crosses the x-axis. Point-slope form is a very important form. It is y minus y1 m x minus x1. It's a way to come up with an equation for a line. Direct variation are like the parent functions. It comes in the form y equals kx, and k is called the constant of variation. So the constant of variation then would be y equals y over x. Basically, direct variations, let me add in there, they always go through origin. They always go through 0, 0. So if you ever have a straight line, they're also always straight. If you have a straight line goes to the origin, direct variation. All right. Interesting. Almost done. I'm not sure why this is blue, but scatter plots are just an organization organization of points on a graph. Positive correlation rises to the right. Negative correlation falls to the right. That means for this one, positive slope goes up to the right. Negative slope falls to the right. Correlation coefficient is a number associated with a line fits, how a line fits some data. So you're going to have a bunch of, in a scatter plot, you'll have a bunch of points. Draw a line through those points, and the correlation coefficient is how close that point is. A best fitting line is the line that matches in a scatter plot. An absolute value function, I'll just give you the parent function. So that's the parent function. And then you're going to see something like this much later in chapter 2, a x minus h plus k. This you would say is the child function. Vertex of an absolute value graph. When you're looking at y equals a absolute value of x minus h plus k, the vertex is at hk. We're going to talk about this when we do the notes, so don't worry. A transformation changes size. Basically either makes a graph bigger or smaller. Translation only moves a graph. So you can move it up, you can move it down, right and left. A reflection goes ahead and it, you can kind of flip it over a line or point. All right, so those are your words to review. All right, go ahead and fill those out, and when you're done, find the 2.1 video online.